All right, recall in an earlier video we looked at the graph of 1 over x and what that looked like, and we had this graph that looked like this. Use your knowledge of rational functions to determine the following limits. Well, here uh, the graph is not 1 over x, it's 1 over x plus 4 squared. Well, think about some of the things we know. What made this graph have something weird going on here? You can see that there is an asymptote at 0. And why is there an asymptote at 0? Well, what number, if we plug it in here, gives us division by 0? 0. So this graph of 1 over x plus 4 squared also has an asymptote. Where's the asymptote going to be? Well, it's going to be at the point that gives it division by 0. What number, if we put it in place of x here, would give us dividing by 0? Negative 4, because negative 4 plus 4 is 0. So this graph at negative 4 is going to have an asymptote there. What else is going on in here? Well, we also have that this is squared. Remember from working with rationals, if it's squared, it's going to go the same direction here. So this one is not going to go opposite direction like that 1 over x one. Both sides here should be approaching the same thing. So let's look at what our limits equal now. What's the limit as x approaches negative 4 from the left? Well, that's going to equal infinity. What's the limit as x approaches negative 4 from the right? That also equals infinity. And so does this one have a limit here? Since both sides are approaching the same thing, we would say that this one also equals infinity. So if they're approaching the same thing, then we can say that it does have a limit there, and use either infinity or negative infinity if both sides are approaching that infinite value. All right, determine each of these limits. On A, we're approaching 2 from the left. Well, 2, you can see here, is going to give us an asymptote. So this is either going to be approaching positive infinity or negative infinity. How do we figure out which one it is? Well, if we look at what happens just before 2 from the left, pick a number that's coming from the left, so a number like 1, and see, do you get a positive or negative number if you put 1 in here? If we were to put 1 in here, 1 minus 4 is going to be negative 3. 1 minus 2 is negative 1. 2 negatives is going to make a positive number, which means to the left of this asymptote, it's positive, and so this would be positive infinity here. What about if we do the same function and approach 2 from the right? Well, again, there's an asymptote at 2. What's happening to the right? Well, let's pick a number to the right, like 3. If we put 3 in here, we're going to get negative 1 over 1. That's a negative number. So you can see that it's approaching numbers that are negative here. So this one's going to approach negative infinity. So if there was a follow-up question on this one, what's the limit as x approaches 2 then of this function? Well, here, since these are not equivalent, then we would say that this one does not exist because they're not approaching the same thing. So they'd have to be the same in order for you to either put infinity or negative infinity. What about the limit as x approaches pi over 2 from the left of the tangent graph? Well, remember we've looked at, in previous years at these trig function graphs. So if we're looking at the tangent graph here, as we approach pi over 2 from the left, what's our graph doing here? There is an asymptote at pi over 2 on the tangent graph, so this is approaching positive infinity here. What about the limit as x approaches pi over 2 from the right of the secant graph? So same thing, let's find our secant graph here, that's this one. As we approach pi over 2 here from the right, our graph looks like it's approaching a negative infinite number because there's, again, an asymptote here. And so the answer to this one would be negative infinity. All right, so infinite infinite limits, you can, if there's an asymptote going on, you can use infinity to describe it. Last example here, use this graph to determine all the following limits. So I want you to pause the video, try these out, and see what you come up with. All right, let's check it out and see what you got. For this first one, as you approach -1 from the left here, you can see it's increasing, so that would be infinity. -1 from the right, that does have a value there. It looks like it should equal 2. Negative, what is the limit then as you approach -1? These are not matching, and so that limit does not exist. What is g at -1? If you look there, it's an asymptote. There is no value there, so that also does not exist. Limit as you approach 2 from the left. 2 from the left, here's our value of 2 there. Looks like it should equal 1. 2 from the right also looks like it should equal 1. Those are matching, and so this would be 1. Is there a value at 2? Absolutely, it is filled in there, so that's also equal to 1. So this would be continuous since the limit is equal to the function value, and you can see from the graph it is continuous at 2.